emissions. This is one of the topics very close to my heart because of what I did before. I know if you try to read the title, if you're not very keen follower of sustainability, some of these words might be new to you, like water security and circular economy, upcycling, downcycling, all type of cycling. I will introduce all of them one at a time in the first couple of slides before I can introduce some examples to you, okay? I don't include any equations in my talks. Most of the time, I talk about my experiences. I'm doing storytelling. You can hear me okay, right? Yeah, all right. So this actually is about my life too, a little percentage of my work life. Now, about 10 years ago, actually, this is 2024, so about 11 years ago, I got this unique opportunity to join the United Nations as a professor, as a capacity developer, in multiple roles. Why am I calling it a very unique opportunity? Because most of the time, faculty members, university people, or academics, they don't get to see this kind of things, like things happening at the ground level, talking to people, capacity development. So that's why I call it a very unique opportunity. I can use like 10, 15 keywords to explain my experience or my job definition. Teaching, research, capacity development, some type of diplomacy, traveling, talking to people, there was a whole bunch of them. But I can lump them up all around this one topic. This is what we call WEF nexus, water, energy, food nexus. Those who are following UN updates, you have seen this before, WEF nexus. Or you can rearrange the words and call it different type of acronyms, but I go with WEF. Now, water, food, energy. What is so unique about water, food, energy? These are the three things essential for our survival as a species. If you're in a city, if you're in a country, if you're in a region without food security, without water security, without energy security, you don't have future. You don't have any survival. You will extinct. You have no chance of surviving. So it is very important. Now, we don't have time to talk about all of them. I selected one, water security. They're all important. And not only that, they are all intertwined. They are connected to each other in very complicated way. One supports the other. If you try to manage one of them in a specific way, there is an impact on the other two as well. They are all related to each other in a good way and a bad way too. So now, water security. Before we talk about water security is related to, well, I mean, in simple terms, it's about whether you have water or not, right? Whether you have enough water or not. By the way, if you have any questions, please note them down. We'll talk about them at the end, okay? Good? All right. So water security is basically about whether you have enough water or not. Now, this is not necessarily about what you think at home, you know? Do I have enough water to drink? Do I have enough water to take a shower? Do I have enough water to wash my car or wash my clothes? No, not necessarily about the direct usage. The list I gave you now, it's only about the direct usage. Indirect usage is much more than that. A lot of industries that we need for our survival need water too. Okay, so let me ask you a question. Out of all these industries we have around the world, there's one industry taking a huge percentage of, I hear an echo. Let me try to keep a distance maybe. Okay, one industry is taking a huge portion of the The global water usage. Can you guess what? What industry is that? One industry. You can't miss it. If you don't know the answer, I think we had to do some catching now. Excuse me. Construction? No. Sorry. Yes, sir. Agriculture is the answer. And can you guess or can you tell me what it is as a percentage? Do you want to try? Yes, sir. 60%. Okay. Any more takers? Any more answers? Yes, sir. 85. Okay. Any more answers? 40. Okay. All right. Actually, well, I mean, these are all numbers, but to my understanding, the real answer is a range between 70 to 90. So you're very close. Thank you. 70 to 90. Why? Because if it's it is about the development of the country you're talking about. If it's a developed country, it's less because the systems are very efficient. If it's a developing country, it's more closer to 90%. Now, can you think about that? You know, all our potable water that we can actually use for even for drinking purposes, we are using it for our agricultural industry, for agriculture, for it's a broad area. I'm just using one single word called agriculture. Okay, so before we get into anything else, I just want to give you a picture about this hidden water footprint. This is very important because we always think about the drinking water, you know, like for showers and things like that. But no, everything we have in our lives, there is a water footprint associated with the manufacturing process of that. Even this gadget, we wasted some water in manufacturing this. My shirt, what you eat now, your computers, everything. So some examples. One tomato, to produce one tomato, you need 2.5 gallons of water. One sheet of paper, printing paper, three. It's a range, 0.3 to 0.5 gallons, depending on the quality of the paper you're talking about, okay? One steak, beef, not gallons, bathtubs. 11 bathtubs. If you convert this to gallons, it's like 880, so almost 900. If your steak is little more than 8 ounces, you're talking about 1,000 gallons, okay? And the other one, I'm not even going to convert. You can see that, but at least when you buy a pair of pants, you're going to wear it for a couple of years, not like the other three examples. These have a temporary, well, I mean, they all serve a purpose, but they have a temporary lifespan, right? Okay, here's something I use in my talks to put things into the perspective, the middle two. We all grew up in this recycling era. Yeah, we are all happy about contributing to recycling. Dr. Yudin already know this story because I told him this story when we were having dinner in Colorado about 4 months ago. Okay, going back to recycling. We all don't, just tell me, admit, please. Are you not feeling happy the minute you skip printing something that is not essential? You just make that decision. Okay, I'm not going to print this, you know. Well, I don't need it, right? We feel happy, right? That's the way we have been trained to think. Recycling is good. So paper, we are saving paper. We are not printing. We make that decision based on our understanding. Okay. Let's say I decided to skip printing 10 pages today. I'm happy. I contributed to the course of sustainability. I saved. Okay, this is a range. I'm going with 1 gallon. Okay. It's a range, 0.5 to 3 gallons. Let's go with 1 gallon. I just saved 10 gallons of water in the water footprint. I'm very happy. Now I go home for dinner. I'll have a steak, which is 9 ounces. I contributed to this course of sustainability with saving 10 gallons, and I just ate up 1,000 gallons. Can you understand? Do you ever feel bad about eating a steak? No. Why? Because we don't understand the basics of sustainability. I mean, I know Guam, okay, I lived here long enough, 6 months, to understand how important it is to have meat in your meals. But compared to all other types of meat, cattle industry is one of the most unsustainable things we have around us. I'm not going to talk about it. It's not part of the topic. But I hope you got the picture now. Water is very important, not only directly, indirectly as well. And the way we think, we have some issues. All right, so this is a real picture. Areas of physical and economic water scarcity. Now we're talking about water security. So water security is about having or not having water, right? Look at the color scheme. There are two regions. Some are red and some are orange. The difference is there are two types of water scarcity. One is economic water scarcity. I'm in your way, right? Can you see that somewhere? Yeah, okay. So one is economic water scarcity. The other one is physical water scarcity. The economic water scarcity happen when you have water, but you don't know how to manage it. Look at this map. You know where Bangladesh is, right? You? They get frequent floods. Every year they get like 5 or 6 floods. It's red. Why? We don't know how to manage it. Look at this, Sub-Saharan Africa. Thick forest, a lot of water. We don't know how to manage it. It's red. This is economic water scarcity, which I assume we can tackle if we come up with a better management process, right? The real issue is physical water scarcity. Physical water scarcity means that you don't have water, period. So if you don't have water, we're talking about dry areas, basically, MENA region, Middle East and the North Africa region, this region. Okay, one comment. Look at the date, 2007. My data is old. I do understand this is an old map, but believe me, this has not gotten better. Okay, this picture is like 15, 16 years old, but it has not gotten better. It's the opposite is true. But I like this because it doesn't necessarily, it is not based on the country boundaries. Rather, it is actually looking at regions. And look at this region. California, Southern California, Arizona, New Mexico, and then maybe like half of Mexico. They all share the same issue. And Australia too. Yeah. So you can understand that it's not really about developed countries versus developing countries kind of issue, you know. I mean, I gave you two examples, US and Australia, we still have this problem. Going back to the physical water scarcity. When you don't have water, what do? You have to think of some other water sources that you haven't used before. There can be a couple of examples. I'm not going to name them, but I will just say one answer. The answer is circular economy. The answer is circular economy. So what is circular economy? Anybody heard that word before, circular economy? Okay, I'm going to explain it to you. Circular economy is a term that we coined to distinguish what we have now versus what we would like to accomplish, okay? So now, please don't pay attention to this little arrow, the circular arrow here, the middle one. Just disregard that, okay? This is a representation of our economy, how our economy works in general. We take resources from the nature, we make things for our benefit, we use them. What happens next? We are very good at sending them all to the landfills. This is not sustainable. So this is a linear process. It goes in a line. It's not sustainable. Why? Because maybe 500 years ago, it was okay because we had, I mean, at least we had a lot of things and population was less. Not anymore. Population is going up and we have limited resources and our taste has changed too. We want more. So circular economy is the answer because we only have one planet to borrow from. Circular economy, what is it? Circular economy tells you that reduce the amount you borrow from nature But whatever we have already in circulation among us, maximize it. Recover the used ones, old ones, put it back in the economic cycle. Put it back in the economic cycle. Metal is a good example. We are actually doing a good job with metal, like 91% of recyclability rate. Paper, we are doing okay job too, some 58%, I think. So now there is a trend that me. Okay. Thank you. Thanks for the tip. Yeah. Um, Now you're seeing this arrow. It's going back a little bit. We want to widen this. If you want to know the number, we are only 8% circular. Our economy is only 8% circular. 92% goes in here. We want to expand this. We're not doing a good job. If this is 100%, this tiny little width of this tiny little arrow is 8%. That's what I meant. Okay. Now, years ago, about 500 years ago, before we became industrialized, our lives were so simple and our waste was predominantly organic. You know, it went back to the nature. We didn't have plastics. We didn't have anything like concrete. So we were actually circular before, but everything changed in the past, especially past 250 years. And with plastics, now we have completely, we have gone crazy. This is not correct. We have to go back to the circular economy. This is the way, right? Now, why am I bringing this? Circular economy. You can understand metal. You can understand paper. We can recycle. We can recover. Can we do that with water? Can we? Yeah, sure, we can do that. It sounds unpleasant, right? Okay, I did it again. It sounds unpleasant, but there is no other way. I mean, even in some regions in the world, it is prohibited by the local cultures and even religions. There's no other way. I mean, it's a resource. Let me ask you a question. Let's say there is a 1 million population living in a city in a dry area. Okay, dry area, 1 million people. If it's an arid zone, people start complaining about not having water, enough water to do agriculture. Guess what? 1 million people are already living there. What do? They take showers, they drink. What happens to the wastewater? It's right there. If it's a city, there is a collection system. That means you have this as a resource. You're not capitalizing on it. That's the only difference. Okay, so the solution is right there. I'm not saying that it will actually satisfy the entire demand. No, but it can be a new water source. As a matter of fact, this is already happening around the world. Now, one last definition, and I'll start talking about some examples, okay? We grew up in a recycling world. So recycling is something I don't have to explain to you. I don't have to define. But nowadays, you might be hearing these other two words too, upcycling and downcycling. What is this? It's all about the economic potential. So if you try to recycle or recover something, and if you can retain the value, like a soda can, aluminum soda cans you can recycle, and when you recycle, it comes back as another aluminum can. You retain the value, that's recycling, okay? Now you understand the other two. If the value goes down when you recycle for the second time, paper is the best example. People have this misconception that you can recycle paper forever. No, it's wrong. Every time you recycle, every round, the length of the fibers, it gets shortened. You cannot recycle forever. So look at this picture. This is the best example. Good quality paper. Next time you can actually make cardboard. Next time you can make toilet paper. That's downcycling. What is upcycling? Well, you understand the picture. My shirt, one day my shirt can become part of a fancy rug. designer's rug. It's all about the economic value. All right. So we can do this with wastewater, recycling, downcycling, upcycling. Now, what did I do? Okay. I decided to select three examples from around the world to demonstrate this beauty of cycling, one for recycling, one for downcycling, one for upcycling. This is my life experience. All these examples, they have some relevance to me and the work I did. Let me start with New Water project in Singapore. How many of you have heard about New Water in Singapore? Singapore is not very far. Well, I mean, I know you cannot fly easily, but from Guam, you cannot fly anywhere. Huh? Singapore is not very far from here. You just have to pass the Philippines and Indonesia. New Water project in Singapore? No? Okay. Oh, yeah. Thank you, Dr. Wuki. Yes, of course, there is someone who lived in Singapore for 15 years. So thank you. Yes. Have you visited the plant, Tamila? No. Okay. All right. Now, upcycling municipal wastewater to ultra pure water. I'm calling it upcycling. Why? Because they start from wastewater and the end result is ultra pure water. Actually, the value goes up. So this is upcycling. What is this exactly? This is a year I started working. Well, actually, this is a couple of months after I started working for the United Nations. All of a sudden I heard about a UN award going to Singapore just because of this new invention, New Water. So New Water project is essentially a wastewater treatment project, and their objective is to bring it to the drinking quality, potable water quality. Okay. Ever since that, I mean, it was a great example. So I started following and studying, and it became part of my talking points. And a few years after I wanted to go there, I did visit. I had some chats with some of this PUB, Public Utilities Board people too, and I visited the place. And you can see these things are in display. Recycled water. I drank it too. I got a couple of bottles as a visitor. Anyhow, so what is this? Now, before talking about the project itself, let me just tell you a little bit about this country, Singapore, a small island. How small? How small? Can you guess? Yeah, Guam is 215 square miles and Singapore is 275 square miles. A little larger than us, okay? Good thing is they have a mainland right next to it. They're an island. This is an island country, like us, like a tropical island. 1957, they got independence from the Brits. They were merged with Malaysia, so they became a province of Malaysian Union, whatever you call it. 8 years after, they were kicked out of the Malaysian Union. It's the first time a country got independence without asking for it. They became an independent island with no resources. I mean, forget other resources. You need some water to drink at least, right? They had nothing. They had nothing. So the first thing they did was to get into an agreement with the Malaysian government to buy water. So this is Singapore, this is Malaysia, the lower part of Malaysia. They started buying water from a reservoir in Johor Bahru or close to Johor Bahru, the closest city, the city close to the Singapore side of Malaysia. That is the imported water. Now, this is the water portfolio of Singapore as of today. Okay. So there are different sources. Can you see imported water? Even today, they have the capacity to fill it with 50% of imported water to satisfy their demand. Okay. This doesn't add up to 100 because this is the maximum they can bring to the national capacity from each category. Okay. So now I go down here. There's a category called collected water. Collected water is nothing but it's another word for rainwater harvesting. This tiny island, as of now, they have 17 inland reservoirs to collect rainwater. 17. That's a collected water. Well, I mean, you can take water from these reservoirs, treat them, and put them back in the system, right? Desalination is a topic you probably have heard, right? You take salt water, seawater, you desalinate it, and then add the nutrients that you don't see in a normal water quality, so it becomes drinking quality water. You can only do it if you have tons of money. Singapore can afford to buy it. Not everybody can do that. I mean, developing countries, they are not available. They are not able to afford it. This is the last one, new water. Okay. So imported water started a long time ago. Collected water, that happened a long time ago too. Desalination, I don't know when exactly. I think it is the latest after they started the new water project. New water project, there's something wrong about the font. You cannot actually see the last bullet point too. Is there anything we can do, John? Maybe, maybe not. Let me see. I will read it. Okay, we don't have to worry. Well, it's okay. I think you can see the pictures. I use pictures heavily. All right. So the project they actually started doing research because I mean think about it. They started doing research in the 1970s because 1965 you got independence. Now you had to be more strategic about your future, right? You cannot depend on Malaysia. Had to come up with something. So this is one of the things they started thinking about. Why not treat wastewater and put it back in the system? It took about 20, 25 years before they found the path, the right technology. So water treatment usually goes through these three steps, like physical type of filtration, chemical and biological type of filtration, and then disinfection. They did use reverse osmosis, which is a very popular technology, and ultraviolet disinfection. Now, here's the best part of it. Water exceeds the standards set by World Health Organization, WHO. That's why we call it ultra pure water. Ultra pure water has a higher value, higher price. They sell part of this new water to industries that require ultra pure water. Industries like semiconductor industry, and I think some beverage industries too. So you can understand how the economic value goes up. This is my first example. Water recycling. This is something really unusual. I'm sure you're not going to see this. Even if you try to do a search, you might not find a lot of information. So water recycling, I'm going to talk about a very historic concept from Sri Lanka. It's in local language, it's called Elanga, but the idea is cascaded reservoirs to catch rainwater. Now, again, this is something I heard about when I was working for the UN. Shame on me. I didn't know about it when I was living in Sri Lanka. I was born and raised in Sri Lanka, but I didn't know about the concept. I knew about the reservoirs. I didn't know about the concept. Now, in 2017, United Nations Food and Agriculture Organization, FAO, recognized Elanga as a globally important agricultural heritage system. What does it mean? Elanga means cascaded reservoir system for rainwater recycling. How old is this system? At least 2,000 years, 2,000 to 2,500 years old. Okay, before I explain Elanga system, let me tell you a little bit about the geography and the rain or the climate zones in Sri Lanka. This map, the pink or the purple is a dry zone. Here, green is the wet zone, and this is in intermediate. The difference between wet zone and dry zone is not completely dry. Wet zone, it rains all the time like here. The rainfall is like 2,500 millimeters, 2,500 millimeters or more. Dry zone gets little less, only one season. People who lived on this island a long time ago realized that the fertile soil is actually in the dry land. But without water, what can you do? So they wanted to harvest water. There is one rainy season. If you can catch and collect it, and if you can keep it for the entire year, that's a solution, right? So they started making reservoirs for irrigation purpose. So remember, this is 2000 some years ago. This is all about paddy cultivation, rice cultivation. Every dot on this map, every blue dot on this map is a reservoir, man-made reservoir, irrigation reservoir. There are 30,000 dots on this map. So between 2,500 years ago, well, actually, they started approximately 2,500 years ago. In the next 1,000 years, or 1,500 years, they made 30,000 reservoirs. Now, because this happened a long time ago, they have become part of the ecosystem. Now, they don't look anything like a new reservoir, like a man-made thing. It looks like a lake until you see the dam. This is an earth dam. That's how you make a reservoir. Now, what is this system? So let me talk about this system, okay? And then I'll go back to these pictures. I'm not promoting tourism. Maybe I am. But I'll come back to the pictures later. This part is something you can understand. There is a reservoir, there is a village, there is cattle, there is a paddy field, there is an agricultural area. It's a village. This system works. There's nothing unusual about this because it's happened throughout the history everywhere, all other countries too, right? Agree? So this part is not normal. What is unique about this system is what happens in the upstream here. Because actually water gets into this village tank, the last reservoir from bunch of other reservoirs, and they get water from bunch of another reservoirs. And this is why it is called a cascaded system, because it's not one, it is a bunch. And why are they connected and how are they connected? The whole point is this is the village, but their paddy areas are actually here too, far away from the village. Now, if you look at this area gets its water from this reservoir. How many of you have seen paddy fields? What is the type of irrigation we do? Flood irrigation. You just flood the whole damn thing and keep water there for a couple of hours and then let it pass. Where does it go? It goes to the next reservoir. And then it goes to the next reservoir. You collected rainwater, now you're recycling it for the same purpose, irrigation. Back then, we didn't have herbicides, pesticides, or any type of other sides. It was good water. We didn't have to worry about it. So this is the beauty of the system. Now, why these pictures? As a kid, I remember going to this area and seeing reservoirs in the middle of nowhere, like even inside jungles. I didn't understand that. I thought maybe there were people living back then and now there is nobody. No, actually it was done on purpose. These reservoirs, can you see any paddy fields, any agricultural areas nearby? No, there's a purpose behind it. Look at this. This is an aerial photograph and there's no villages, there's no agricultural areas. Paddy fields you can understand from a mile away, you will see them. The point is actually it serves two purposes. If it's a forest, if it's in a forest, it's a catchment. You can collect more water, extra water, right? That's number one. Number two is this. Animals suffer too in droughts. When there is no water, there's nothing for them to, like drink from. So actually, these ones were dedicated for animals, and it became part of their ecosystem. The elephants don't know that it was man-made. They think it's part of the nature. They still come after 2,000 years. They still come and use them. That was designed in that way. It was not a mistake. It was done purposely. Okay, that was recycling. This is downcycling. My last example. Something that happened in Mexico, and I involved myself in this project too, UN project. Wastewater irrigation in Hidalgo, Mexico, use of treated or untreated wastewater in agriculture. This is a tricky one. Can you see this guy? Have you seen him on campus walking around? He had more hair than now, back then, a couple of years ago. All right, Hidalgo, Mexico. Okay, let me give you a little bit of geography lesson. Mexico City. Mexico City is the capital of Mexico. Mexico City is a province by itself. And the province right next to it, um, right north of it, about 160 kilometers north of it, this area, this province is called Hidalgo. And about 125 years ago, Hidalgo had a problem and Mexico City had a problem too. Mexico City's problem was they didn't know what to do with their wastewater. Hidalgo's problem was they didn't know how to find water to do their agriculture. Some smart guy, I don't know who, decided to cut a canal. Actually, now there are two of them. Cut a canal and divert all this used water, wastewater, to Hidalgo area. Fine, it's a win-win back then. They found a solution to get rid of their dirty water. They found a solution to do their agriculture. Now, that was 125 years ago. So the composition of wastewater was, I don't want to say completely harmless, but relatively harmless because it didn't have any chemicals in it. But, well, I mean, of course, if there was some health issues and things like that, yeah, of course. But people survived. They found a solution. They were happy. But the problem was for another 100 years, they forgot that they're doing something wrong. This is not treated wastewater. This is raw wastewater. This is raw sewer. Shouldn't be doing that. It's like inviting for more trouble. But it happened anyways. And by the time they realized that this area, Hidalgo area, is the area in Mexico with the highest incidence of cancer, they knew that something was not right. Cattle and dogs started dying with no reasons, you know. Environmental catastrophe, public health catastrophe too. So now you need to do something to stop. But farmers wouldn't listen to you. Why? Raw sewer has nutrients. You put it in your crop, your yield is very high. You don't have to use fertilizer. So you're saving money on fertilizer. They got used to the concept for 100 years. You know, I mean, if you talk to them, this is how my grandfather grew things too, and his grandfather grew things too. You cannot argue with them. So it's not really a water issue. It's actually a socio-economic issue too. Social and economic reasons. You cannot solve it overnight. Now, so what did we do? Okay, before that, did it again. Right, this is the global picture of how we use wastewater. This is not a problem limited to Mexico. Of course, Mexico is on the top of the list. But look at all these countries. It happens everywhere. Developed versus developing. All these countries, they're doing the same thing, you know? But in a different way. Developed countries, there is a system. So you make sure that you're using treated wastewater. But it doesn't happen in most developing countries. They don't have the money or the technology to do that. Now, it's very dangerous to read between these two lines. You can read the lines, but the meaning between the two lines is very dangerous. 10% of what you eat, yes, food, 10% of what you eat is grown with wastewater. And the second statement, 50% of the wastewater on a global scale does not receive any treatment. It just goes somewhere. It can be the ocean or a sea or a lake or a river. Between these two lines, you can understand there is some danger in it. Yeah. Okay. So WHO actually presents a solution. The solution is based on fit for purpose argument. Now, Do you think we have to bring Singaporean technology to treat it to the ultra pure level to irrigate? No, we don't. If you can treat it to a reasonable level and still keep some nutrients in your wastewater, treated wastewater, it will benefit both sides. You're reducing the risk. At the same time, you're still letting farmers benefit from part of the nutrients in it. This is what we call fit for purpose argument. So that's what we try to encourage. Did we do a good job? Did we solve the problem? I don't think so, but we tried. We helped the local organizations. We did some capacity development type of activities, and this is one of them. Why am I talking to you about this workshop? So, I mean, I explained the idea. We are trying to educate them in a way that they can understand, but it doesn't happen overnight. It's not, you cannot do it with government regulations too, because people would resist. So, policy integration, before you introduce new policies, you had to involve everybody and listen to them and try to convince them and try to learn from them too. Now, why is this two pictures? This is actually the two sides of the same table, okay? This is our workshop, the workshop I did in Hidalgo, 2017, if I'm not mistaken. Yeah. This woman standing and talking here is illiterate. She doesn't even know how to write or read in her own language, Spanish. She's a farmer. She can only speak, but she came and contributed in the only way she can contribute, talking. The woman sitting next to her on her right is a medical doctor. The other young lady here is a university student. This lady here is the highest political figure in that region, like our governor here. And the person sitting next to her is the mayor of that area, city. Can you see the composition of this workshop? A lot of scientific workshops, we pay attention to the scientific folks or the nerds. You can find the best scientific solution, but if you don't know the real grievances of people, you cannot solve them. So I'm happy about how we tried to do it. If you're asking me if we solved the problem, maybe not, but maybe we made some difference. 50 minus 7 is 43. Okay, not bad. Is my little quiz. What did you learn?